So, how do we go? Like integral of secant square x equal to tan x. Of course, a plus c is there to get all the antiderivatives. Okay. First thing, it will be helpful once you go for that elementary functions to know how the sum or you take f x minus g x or f x plus g x, and if you multiply a constant k, so how the integral behaves. That really behaves in the expected manner. That is we say it is linearity of the indefinite integral. See, all that we know that it is coming from the properties of the derivatives. If you take k times f of x and take its derivative for some constant k, then it will be equal to k times f prime x. And if f capital F x is an antiderivative of f of x, we would get k of f x. So, that means the antiderivative of, if the antiderivative of small f is equal to capital F, then the antiderivative of k times small f is k times capital F. So, that is behaving this way with respect to multiplying a constant. If you add or subtract two antiderivatives f x and g x, say capital G x is an antiderivative of small g x. In that case, their derivative is equal to f prime x plus g prime x, which is small f plus small g. So, that means the antiderivatives also behave proper way, right, so to say. So, that means antiderivative of f x plus g x is antiderivative of f plus antiderivative of g. So, together these two are called linear properties of this. So, the indefinite integral, remember that is the general antiderivative with some constant c. So, in that case we just write it this way, that indefinite integral of k f x dx equal to k times indefinite integral of f x. Similarly, integral of f x plus g x equal to integral of f plus integral of g, right. So, this we know that similar properties also hold for the definite integrals. So, which means suppose you are able to find the indefinite integral, then to go to definite integral you just evaluate that at b, at a, and then subtract them. That is how you will be obtaining the value of the definite integral. And of course, we need some repertory that which functions gives which integrals. Okay. We know that derivative of x to the power m plus 1, derivative of x to the power m plus 1 with respect to x is equal to m plus 1 times x to the power m. So, now we write that in terms of integral, or you can bring that m plus 1 here, right. So, we write that in terms of the integral as integral of x to the power m equal to x to the power m plus 1 by m plus 1, right. So, that is how this first formula is related. You take the indefinite integral. So, integral of x to the power m dx is x to the power m plus 1 by m plus 1 plus c for some constant c. And these powers we have defined only for rational. So, let us take m is a rational number, but m is not equal to minus 1, because at minus 1 this will be 0, right. So, m is not equal to minus 1. For minus 1, what will be the answer? So, that will come from the logarithm function, because derivative of log x will be equal to 1 by x. From there it should come, but we have not discussed that yet. So, we do not discuss that now. All that we remember that for m is not equal to minus 1, we can apply this formula. Similarly, if you go to sine of k x, if you differentiate the right side, all that it says, if you differentiate the right side, minus cosine k x by k, c anyway will give 0. So, that derivative should be sine k x, and it is. So, we can write integral sine of k x dx equal to minus cosine k x by k plus some constant, that is the indefinite integral. So, obviously, k should not be equal to 0 to apply this. If k equal to 0, you just get c. So, that term is gone. Now, integral of cosine k x similarly gives sine k x by k, because derivative of sine gives you cosine. So, derivative of tan k x is secant square k x times k. So, we divide by k, tan k x by k, if you differentiate, you would get secant square k x. So, that is why integral of secant square k x equal to tan k x divided by k. Again, k should not be 0. Similarly, integral of cosec square k x equal to minus cot kx divided by k, because derivative of this right side equal to cosec square kx. Then all these formulas we know for the derivative, that is why we are rewriting it for the indefinite integral. Since derivative of secant kx by k equal to tan kx sec kx, so integral of this is equal to secant kx by k plus c. Similarly, the cot x and cosec x formula gives integral of cot kx cosec kx equal to minus cosec kx by k and plus c. We know that derivative of sin inverse x equal to 1 divided by square root of 1 minus x square for mod x less than 1. Sin inverse x is defined only for mod x less than or equal to 1. So, then we write integral indefinite integral of 1 by square root of 1 minus x square equal to sin inverse x plus c. At x equal to 1 it is not defined, this function. So, 1 divided by square root of 1 minus x square is defined for mod x not equal to 1, that is why this happens. Then similarly, tan inverse x has the derivative 1 by 1 plus x square. So, we write indefinite integral of 1 by 1 plus x square dx equal to tan x plus c, tan inverse x plus c. Similarly, secant inverse x has the derivative as x times square root of x square minus 1. So, we divide by 1 divided by mod x square root of x square minus 1, its integral will be secant inverse x for mod x bigger than 1. So, these are all the formulas which will be helpful for us while evaluating the integrals. So, if you do not remember some of them, you go back to the derivatives, see what their derivatives are, and then you can just rewrite all these integrals in that from the information of the derivatives. Okay, so, let us solve some examples basing on this notion. We want to find in the first example the general antiderivative of f x, that means the indefinite integral of f of x equal to 3 x to the power minus 1 by 2 plus sin 2 x. So, it is really 3 divided by square root of x plus sin x. So, what will be its general antiderivative? We go back to the property of linearity and so on. So, we have indefinite integral again, integral of 3 x to the power minus half plus sin 2 x is equal to, by the linearity property, 3 integral of x to the power minus half dx plus integral of sin 2 x dx. Now, x to the power minus half, you apply the first formula, x to the power m integral is x to the power m plus 1 by m plus 1. So, that gives m plus 1 here is minus half plus 1, which is half. So, 3 remains x to the power half divided by half. Then you find the function whose derivative is sin 2 x. So, that also you know it is minus cos k x divided by k. So, that gives cos 2 x divided by 2, minus cos 2 x by 2, and of course, some arbitrary constant might be there because it is indefinite integral. So, you simplify, that gives you 6 square root of x minus half cos 2 x plus c, that is the indefinite integral or the general antiderivative of f x equal to this. So, this is how our formulas will be helpful, formulas and the linearity property. Let us go to the second one. Here we want to find a curve or the curve, there exists only one, that is what the question says, curve whose slope at the point x y is 3x square. So, that means if some curve is there, if you take that point x, so its slope of the at that point, slope of the tangent, right, slope of the tangent at point x y is 3x square. It is varying of course as x varies, and this curve passes through the point 1 minus 1. So, it is really a differential equation we are going to solve, but this can be tackled because of our indefinite and definite integrals. So, suppose what does it ask? Let us reformulate again. We want to find y equal to f of x. So, its slope of the tangent, right, at the point x y, that means f prime x, it is equal to 3x square, and it passes through the point 1 minus 1, which means f of 1 equal to minus 1. right. So, we have f prime x equal to 3 x square and f of 1 equal to minus 1. These two things we have to solve and get what this f can be. So, now since f prime x equal to 3 x square, we have f of x by the fundamental theorem, second fundamental theorem, f of x is integral of f prime x dx, which is integral of 3 x square dx, and 3 x square we know is the derivative of x cubed. So, its integral will be x cubed plus c for some constant c, some real number c. Now, we know f of x is in this form for arbitrary constant c. We have to evaluate that arbitrary constant by using the constant f of 1 equal to minus 1. So, when you take f of 1, this gives on the left side minus 1, on the right side you get 1 cubed plus c. So, c equal to minus 2, right. Hence, f of x is equal to x cubed minus 2. That is how simple differential equations whose derivative is known and a point where the curve passes can be solved. Okay. Let us go to another example. Here we are asked to calculate the area bounded by the curve y equal to 6 minus x square and the x axis. This picture is absent in the problem that we have to get from it. So, sometimes it is helpful to see what is the curve, but even if you do not have the curve, you can still proceed analytically. Okay. So, we know that it is a parabola, inverted one. So, it looks like this, y equal to 6 minus x square. We want to find the area bounded by this curve and the x axis. So, that means it intersects the x axis at least 2 points in order that area should come, and then nothing else is required to get a region which is bounded by these two. We do not have the line x equal to a and x equal to b here, right. So, that means wherever it crosses from those two lines it should come. If you, of course, if you look at the figure, it is making clear this curve is intersecting at 2 points and we want to find this area which is colored blue. So, in order to see what are those points, we must find out first where does this curve crosses the x axis. Okay. So, when it crosses the x axis, that means y equal to 0. So, when 6 minus x square equal to 0, that is our first question, right. So, is to compute the area. So, first we find the intersection, we want to see where 6 minus x square equal to 0. And when this is equal to 0, what if you can factor it? So, the factor is minus of x plus 3 into x minus 2. Let us verify. So, that gives x square plus 3 minus 2, it is plus x, and minus 2, it is minus of this. So, that is what 6 minus 6, 3 into 2. So, that is what 6 minus x square equal to 0. So, that means x plus 3 into x minus 2 equal to 0. You could have taken minus here also, but it is okay. So, that gives you 2 points, x equal to minus 3 and x equal to minus 2. These are the 2 points where the curve crosses the x axis. So, we want to find out the area bounded by this curve and these 2 points. These are really our lines, x equal to a and x equal to b. If you go back to the general setup and you see this is the bounded area, the other one will go unbounded, right. It will go this way, the curve. So, that is the unbounded area, this is only the bounded area. So, you want to find this blue colored area. Then it will be just the integral from minus 3 to 2 as earlier and f of x dx, right, that is the area. So, you get, and we have to see that it is area should be always non-negative. So, this curve in the picture, it lies above the x axis. So, it has to be non-negative, but then analytically we have to see. So, let us take any point x between minus 3 to 2 in x. Then you see that x minus 3 is positive and x minus minus 3 is negative, x is bigger sorry, it is positive, and x minus 2, x is smaller than 2. So, this is negative. So, that means the whole thing is negative, okay, may be equal to 0, at those 2 points it is equal to 0. So, our curve is minus of this thing. So, that should be greater than or equal to 0. That means, for any x inside the interval minus 3 to 2, 6 minus x square is greater than or equal to 0. Of course, it is greater than 0 if x belongs to the open interval minus 3 to 2, right, except the points minus 3 and 2. If x is in between minus 3 and 2, but not equal to them, then it is positive, and at those points it is equal to 0. So, we write 6 minus x square is greater than or equal to 0 for any x in minus 3 to 2. So, that means the curve lies above the x axis, and when you take bounded by this x axis, automatically that area becomes positive if you compute the definite integral. So, the area will be equal to the definite integral. This is area, required area, that is the definite integral from minus 3 to 2, okay, not from 2 to minus 3, that will be negative of that, minus 3 to 2 of 6 minus x square. In fact, our area should be coming like minus 3 to 2 mod f x dx, where minus 3 is less than 2. If it is 2 to minus 3, then it should be minus of mod f x, right, because it will introduce a negative sign. So, that is the area. Our area is minus 3 to 2, mod f x is greater than or equal to 0 here. So, mod f x is f x itself, 6 minus x square dx, that is equal to 6 x minus x square by 2 minus x cubed by 3, because from 6, when you differentiate 6 x, you get back 6. So, integral of 6 should be equal to 6 x, and when you differentiate x square by 2, you get x. So, integral of x is x square by 2. Similarly, if you differentiate x cubed by 3, you get x square. So, integral of x square is x cubed by 3, and using the linearity property, we just write 6 x minus x square by 2 minus x cubed by 3. And the connection between definite and indefinite integral is, whatever indefinite integral you get, it should be evaluated at minus 3 and 2. In fact, you should get plus c as the indefinite integral, but that c will get cancelled, because when you evaluate at minus 3, same c remains when you evaluate at 2 also. So, they get cancelled. So, how to evaluate this? It will be 6 into, at the first point, f of b minus f of a, b is the top one, it is 2 here. So, 6 into 2 minus 2 square by 2 minus 2 cubed by 3. This expression, it is f of b minus f of a at minus 3, similarly 6 into minus 3 minus minus 3 square by 2 minus minus 3 cubed by 3. This is the expression. So, if you simplify it, it will turn out to be 125 by 6. Now, here it so happens that the curve is equal to mod f x. So, it is the actual area, but if you take the signed area, where you just take, instead of mod f x, you simply take f x dx, integral minus 3 to 2 f x ds. That happens to be same here, because the function itself is lying above the x axis. Okay. So, that is how we will be computing signed areas and unsigned areas. Okay. So, let us stop here.